Hello there, and welcome to the Sleepy Science Channel. Tonight, we'll wander into a hidden kingdom that lives all around us, and yet is so often overlooked: the world of mushrooms. Mushrooms are not quite plant, not quite animal, but something in between, a realm of their own. They breathe like we do, they grow in silence, and they've been shaping the life of this planet for longer than forests have existed. Some glow in the dark like lanterns scattered across the night. Some stretch vast and unseen beneath our feet, weaving together the roots of trees in a secret language. Others dazzle with colors so bright they look painted by hand, while a few hold poisons so deadly that a single taste could end a life. And yet, mushrooms are also healers, builders, recyclers, and dreamers. They make bread rise, they turn grapes into wine, they can clean the world of oil and plastic, and they may even help us imagine how life could survive on other planets. If you enjoy these science explorations, feel free to like and subscribe, or share a thought in the comments below. It helps others find their way here too, one sleepy soul at a time. But for now, let's begin. Mushrooms are more closely related to animals than plants. It surprises most people to learn that mushrooms, despite living quietly in forests and sprouting from soil like flowers, are actually closer relatives to us than they are to trees. At the genetic level, fungi share a common ancestor with animals, not plants. They breathe in oxygen and exhale carbon dioxide, just as we do. Their cell walls are not made of cellulose, like plants, but of chitin, the same tough material that makes up the shells of insects and crustaceans. This strange kinship places fungi in a hidden family branch we rarely think about. When you walk through a forest, it may look as though mushrooms belong alongside the leaves and flowers, but in truth, their closest companions are creatures that walk, swim, and fly. To know that a mushroom is, in a way, more like us than like a blade of grass, can change how you see the forest floor forever. Some mushrooms glow with their own natural light. Imagine walking at night through a forest where tiny lanterns are scattered in the moss. Mushrooms glowing softly, green or blue, like fairy lights woven into the ground. This glow is called bioluminescence, the same kind of light that fireflies and some deep-sea creatures produce. More than 70 known mushroom species can shine this way, including the aptly named foxfire fungi. Scientists believe the glow might attract insects at night, helping the mushrooms spread their spores farther, or perhaps it simply protects them from being eaten. The glow comes from a chemical reaction involving an enzyme called luciferase, the same family of reactions that give fireflies their spark. To see one of these mushrooms in the wild is to witness an ancient magic, living light born from decay, proof that even as wood rots and breaks down, beauty can still shine through the darkness. A single fungal network can cover miles underground. Beneath your feet, hidden in the soil, there may be a living web so vast that it stretches for miles. Mushrooms are only the fruiting bodies, the visible tips, of a much larger organism called mycelium. Mycelium is made of delicate thread-like filaments that weave through the earth, wrapping around roots, stones, and even the remains of fallen leaves. In some places, this network is unimaginably large. A single mycelial organism can extend across hills and valleys, linking thousands of trees together. Imagine a net made of life, invisible yet alive, silently working under the forest floor. Through these networks, fungi recycle nutrients, carry water, and even help plants trade resources with one another. It is as though the earth itself has veins, pulsing with hidden threads. To walk across a patch of grass might be to step unknowingly on a single massive creature, ancient, quiet, and everywhere. The largest living organism on Earth is a mushroom. In the Blue Mountains of Oregon lives something extraordinary. At first glance, it looks like an ordinary forest. Pine trees, streams, and meadows. But hidden beneath the soil lies the largest living organism known on Earth, a single fungal network of Armillaria ostoyae, often called the honey fungus. This colossal mycelium stretches for nearly 4 square miles and is thought to be thousands of years old. Every mushroom you see popping up from the ground, there is just one tiny piece of this enormous creature. To put it in perspective, this one organism outweighs the largest blue whale many times over and has silently lived longer than most civilizations. When scientists discovered its true size, they realized that the forest they were walking through was not made of countless individuals, but of one vast being, sprawling and ancient, thriving beneath their feet like the pulse of the earth itself. Mushrooms can communicate with electrical signals. Though mushrooms have no brains or nervous systems, they send pulses of information through their mycelial threads. These signals resemble tiny electrical impulses, not unlike the firing of neurons in animals. Some scientists have found that the patterns of these pulses even look a little like words, with changes in frequency possibly carrying meaning. Through this system, fungi may share information about danger, resources, or environmental conditions with other parts of their network. It's as though an underground internet is woven into the soil, transmitting signals in a language we're only beginning to decode. Imagine trees sending sugar to one another, with mushrooms acting as the couriers, passing the message along. While it may not be thought in the way humans understand it, it is communication all the same. A reminder that intelligence takes many forms, and the Earth hums with conversations we cannot hear. Some species can survive in space. When scientists tested what life could endure beyond Earth, they brought spores of fungi along. To their amazement, some species not only survived exposure to the vacuum of space, but also endured intense radiation and freezing temperatures. The spores floated outside spacecraft for weeks, shielded only by their own natural toughness. When brought back to Earth, many were still alive and capable of growing. This resilience makes fungi fascinating candidates for astrobiology, the study of life beyond Earth. If mushroom spores can survive the void, it raises the possibility that life could travel between planets, riding meteorites or dust across the cosmos. The idea is called panspermia, and fungi are proof that such journeys might not be impossible. Imagine the humble mushroom, often overlooked in the forest, carrying the spark of life across galaxies, waiting to bloom again wherever it finds soil, water, and light. Mushrooms have been found growing in nuclear reactors. After the Chernobyl disaster in 1986, scientists studying the ruined reactor were startled to find something thriving in the ruins: fungi. Certain species, including Cryptococcus neoformans, not only survived in the radioactive wreckage, but seemed to grow toward radiation itself. These fungi contain melanin, the same pigment found in human skin, which may allow them to convert radiation into chemical energy, almost like photosynthesis with radiation instead of light. It's as though these mushrooms are eating radiation, transforming what we see as deadly into fuel for growth. This discovery has huge implications for the future. One day, fungi could help clean up nuclear waste or protect astronauts from cosmic radiation on deep space journeys. In the darkest, most dangerous places on Earth, mushrooms have found a way to live, and perhaps even to thrive. Fungi can digest plastic and oil. One of the most hopeful discoveries in recent years is that some fungi are natural recyclers on a grand scale. Certain species can break down materials that usually persist for centuries, such as plastic and petroleum. In 2011, researchers found a fungus in the Amazon rainforest capable of eating polyurethane, one of the most stubborn plastics in use. Other fungi have been shown to digest oil spills, transforming toxic waste into harmless matter. Imagine landfills shrinking not by human machines, but by quiet fungal colonies feasting away. Scientists are now exploring how these mushrooms could help us tackle pollution, perhaps one day designing fungal biofactories that could devour plastic waste. In a world overwhelmed with what we throw away, fungi remind us that nature often holds the tools to heal itself, if only we are wise enough to listen and learn from them. There are mushrooms that can kill you with a single bite. Among the many wonders of mushrooms, there is also danger. Some species carry toxins so powerful that even a small taste can be fatal. The death-cap mushroom, Amanita phalloides, is one of the deadliest. Its poisons silently destroy the liver and kidneys, and symptoms may not appear until it is too late. What makes it even more chilling is how ordinary it looks, a pale greenish mushroom that could be mistaken for something edible. Throughout history, deadly mushrooms have claimed the lives of kings, peasants, and even whole families who did not know the risk. The line between food and poison in the fungal kingdom is razor thin and often invisible. Yet in this danger lies fascination. How a fragile-looking mushroom can hold enough chemistry to unravel a human life reminds us that nature, though beautiful, must always be respected. Others taste almost exactly like lobster or chicken. Not all mushrooms bring danger, some bring delight. Certain species have flavors so striking that they mimic meat or seafood almost perfectly. The lobster mushroom, for example, has a bright reddish-orange color and a taste that recalls the sweetness of shellfish. Chicken of the woods, with its layered fan-like shape, tears apart in chunks that resemble chicken breast, both in texture and taste. For centuries, foragers have treasured these mushrooms as natural alternatives to meat, long before plant-based diets became popular. To bite into one is to experience the strange versatility of fungi, how something growing silently from the bark of a tree can taste like a feast from the sea or the farm. It's as if mushrooms are shapeshifters of flavor, borrowing tastes from the animal world while remaining firmly in their own mysterious kingdom. Ancient cultures used mushrooms in sacred rituals. For thousands of years, mushrooms have held a place not only in kitchens but also in temples and ceremonies. Ancient peoples saw something mystical in the way mushrooms seemed to appear overnight, as if conjured from nothing. In Siberia, shamans used the redand white Amanita muscaria, the iconic fairy tale mushroom, in rituals to enter trance states. In Mesoamerica, the Aztecs referred to sacred mushrooms as Teonanacatl, meaning the flesh of the gods, and they used them in ceremonies to connect with the divine. Even cave paintings in Spain, thought to be over 6,000 years old, show figures holding mushrooms. These fungi weren't just food. They were doorways to altered states, visions, and spiritual journeys. To our ancestors, mushrooms seemed like messages from another world, sprouting mysteriously from the earth to remind humans of the thin veil between the everyday and the extraordinary. Some mushrooms take over the minds of insects. One of the most eerie and fascinating phenomena in nature is caused by fungi, known as cordyceps. These mushrooms don't simply grow quietly in soil, they infect insects, taking control of their very behavior. A spore lands on an ant, and soon the fungus begins to spread inside its body. Eventually, it manipulates the ant's mind, forcing it to climb up a stem or tree to the perfect height for spore dispersal. There, the ant clings motionless, as if frozen. Then, the fungus bursts through its body, growing a strange stalk that releases spores to infect others below. This gruesome cycle has earned cordyceps the nickname zombie fungus. Though chilling, it is also a reminder of how fungi have evolved ingenious, if unsettling, strategies to survive. The forest floor hides entire dramas, where even insects can become unwilling puppets in the mushroom's silent play. A fungus once wiped out entire populations of amphibians. In the late 20th century, biologists began noticing frogs, salamanders, and toads disappearing across the world. The culprit turned out to be a fungus called Batrachotitrium dendrobatidis, or BD for short. This fungus infects the skin of amphibians, disrupting their ability to breathe and regulate water. Because amphibians absorb much of their oxygen and moisture through their skin, the infection is often fatal. Whole populations vanished seemingly overnight, and the fungus has been called one of the most devastating pathogens in recorded history. To think that something so small, invisible to the casual eye, could reshape entire ecosystems shows the hidden power of fungi. Even now, conservationists are racing to protect vulnerable species, developing antifungal treatments and breeding programs. The story of BD is a sobering reminder. Fungi are not only helpers and recyclers, but sometimes destroyers, changing the course of life on Earth. The air you breathe is full of mushroom spores. Every breath you take carries with it tiny pieces of the fungal kingdom. Mushroom spores, the microscopic seeds of fungi, are so abundant that billions swirl invisibly through the air around us at any moment. They drift through cities, forests, and oceans, falling with raindrops or floating for miles on the wind. Scientists estimate that each cubic meter of outdoor air can contain thousands of spores. You inhale them without ever noticing, yet your body is adapted to this hidden rain of life. In fact, spores are one of the most common biological particles in Earth's atmosphere. They are so small and light that they can even ride currents up into clouds. In a sense, every breath connects you to forests and fungi far away, linking your lungs to ecosystems you may never see. You are always breathing in the silent presence of mushrooms. Spores are so light, they can float in the stratosphere. Unlike seeds, which are often heavy and bound to soil, spores are designed to travel. Many are so tiny and lightweight that they can remain airborne for astonishing lengths of time. Some have been detected more than 20 miles above Earth's surface, floating in the stratosphere. There, they may hitch rides on high-altitude winds, drifting across oceans and continents. Spores are equipped with protective coatings that shield them from ultraviolet light, dryness, and even radiation, allowing them to survive such journeys. This ability to travel vast distances makes fungi some of the most successful colonizers in nature. Imagine a single spore released from a puffball mushroom in a meadow, rising into the sky, and months later settling into soil on the other side of the planet. Spores turn the atmosphere itself into a highway for life, invisible yet unceasing, connecting ecosystems across the globe. Some spores can survive a trip through space. In experiments where spores were exposed to the vacuum and radiation of outer space, many managed to endure conditions that would kill most organisms instantly. Tucked within their tough protective coats, spores survived not just for hours, but sometimes for weeks, floating outside spacecraft or attached to satellites. This resilience has inspired the idea of panspermia, that life could spread between planets via spores or microbes carried on meteorites or dust. If fungal spores can survive such journeys, it suggests that life might be more portable than we once thought, perhaps traveling across the solar system or even the galaxy. When you see a mushroom releasing a cloud of spores, you are watching a survival strategy so efficient that it might extend beyond Earth itself. They are tiny explorers, hardy enough to endure the void, waiting for a new world to call home. mushrooms can break down stone over time. We often think of stone as eternal, but even rocks are vulnerable to the slow persistence of fungi. Some species of lichen, a partnership between fungi and algae, secrete acids that can break down minerals, gradually wearing stone into soil. Over centuries, this process transforms mountains, cliffs, and boulders into fertile ground where plants can grow. Without fungi and lichens, the world might remain locked in bare rock, unable to support lush forests and grasslands. In a sense, fungi are Earth's earliest gardeners, preparing the way for all the green life that followed. Even today, on old tombstones or ancient ruins, you may find small fungal patches slowly etching patterns into the stone. With patience measured in centuries rather than days, fungi quietly reshape the solid bones of the world, proving that nothing is beyond the reach of their persistence. Certain fungi create fairy rings in meadows. Step into a grassy field after rain, and you may find a circle of mushrooms, perfectly round, as though left behind by fairies dancing. These are called fairy rings, and they form as a single fungus spreads outward in all directions underground. The mushrooms you see are just the tips of the advancing edge of the mycelium. Over time, the circle widens, sometimes growing larger each year. In folklore, fairy rings were thought to be magical places, doorways to another realm, or traces of nightly dances by unseen beings. Scientists know now that the rings are simply the natural growth of fungi, but the sense of wonder remains. To see a fairy ring is to witness geometry alive in the grass, a living circle drawn by threads you cannot see, connecting the ordinary meadow with something timeless, secret, and enchanted. Some mushrooms can appear overnight after rain. There is something astonishing about the suddenness of mushrooms. One day the ground looks bare, and the next morning it seems dotted with new life. Mushrooms can grow incredibly quickly, sometimes pushing up through soil or leaf litter in just hours. Their growth is fueled by the hidden mycelium, which stores energy until conditions are just right. Rainfall softens the ground and provides the moisture needed, and then the mushroom surges upward, unfolding like a time-lapse miracle. This sudden appearance has given mushrooms a mystical reputation in folklore, as if they are conjured by spirits or magic. In truth, it is biology at its most efficient, years of invisible preparation leading to one spectacular emergence. The next time you see mushrooms after a storm, remember that they were already there, waiting patiently for the signal to rise into the light. Mushrooms have been used as natural dyes for cloth. Long before synthetic dyes, people discovered that mushrooms could color fabrics with surprising brilliance. Different species can produce shades of gold, green, purple, red, and even deep blues. Some dyers still forage for mushrooms like Phaeolus schweinitzii, known as the dyer's polypore, which can create rich yellow and orange tones. Others turn to lichens for delicate pinks and purples. Each mushroom species contains unique compounds that, when boiled with wool or silk, release pigments that bind to the fibers. These dyes are natural, renewable, and often create colors that shift subtly in the light. Wearing mushroom-dyed clothing once meant carrying a piece of the forest with you, its hues woven into fabric. Even today, artisans revive this tradition, celebrating fungi not just as food or medicine, but as artists of color, painting the world with palettes hidden in the soil. Some fungi can trap nematodes to eat them. Fungi are often thought of as quiet decomposers, breaking down wood and leaf litter. But some are hunters. Certain soil-dwelling fungi have evolved ways to trap and consume nematodes, tiny, thread-like worms that wriggle unseen through the dirt. These fungi build microscopic snares, sticky nets that catch passing worms, or even elegant lasso-shaped rings that tighten like nooses when touched. Once caught, the fungus pierces the nematode and drains its nutrients, fueling its growth. To think of a mushroom acting like a predator, weaving invisible traps in the soil, changes how we imagine them. They are not passive beings, but cunning survivors, capable of hunting without eyes or movement. Beneath your feet, there may be entire battlefields of fungi and worms, unseen but constant, with each victory feeding the slow, patient expansion of the fungal kingdom. Mushrooms can be stronger than steel in structure. Though mushrooms look delicate, their architecture can be astonishingly strong. The fine threads of mycelium weave into a dense, interlocking network that rivals some of the toughest materials known. In fact, tests have shown that certain mycelium composites can be stronger than steel when measured by weight. This strength, paired with their lightness and biodegradability, has made fungi a focus of material science. Designers are now experimenting with mushroom-based building materials, bricks, insulation, even furniture, that are durable, fire-resistant, and fully compostable when no longer needed. It's remarkable that what looks like a fragile toadstool in the forest can inspire structures sturdy enough to support homes. Mushrooms remind us that resilience is not always loud or visible. Sometimes it is woven silently, fiber by fiber, into networks that are humble in appearance but extraordinary in strength. Fungi were among the first organisms on land. Long before trees stretched toward the sky or flowers opened their petals, fungi had already stepped onto the shores of ancient Earth. Fossil evidence shows that fungi colonized land over 1 billion years ago, helping to break down rock into soil. In doing so, they prepared the world for plants to follow. Some scientists believe enormous fungal towers once dotted the land hundreds of millions of years ago, standing over 20 feet tall. These strange organisms, called prototaxites, may have been the tallest living things of their time. Imagine a barren, alien landscape where giant fungal spires rose above the ground long before forests or grasslands existed. Without fungi to pave the way, the Earth as we know it, fertile, green, and alive with plants, might never have emerged. They were the quiet pioneers of land life, shaping the world with patience and persistence. Some mushrooms are so small they fit on a pinhead. When most of us picture mushrooms, we think of caps large enough to pick, cook, or photograph in a forest. But in the hidden microworld, some mushrooms are so tiny they can balance easily on the head of a pin. These miniature fungi sprout like specks of dust on decaying leaves or fallen twigs, often visible only under a magnifying glass. Despite their size, they still perform the same essential work as larger mushrooms, breaking down matter and releasing spores. Many of these micromushrooms create delicate, almost crystalline structures, with caps no bigger than grains of sugar. To imagine that such fragile, fleeting life forms exist all around us, unseen, is humbling. The forest is not only filled with towering trees and large mushrooms, but also with tiny realms of life that thrive in spaces too small for our eyes to notice. Others can grow to be larger than a human. At the opposite end of the spectrum, some mushrooms grow to astonishing sizes. The giant puffball mushroom, for example, can swell to the size of a beach ball, with some specimens weighing over 20 pounds. When mature, a single puffball can release trillions of spores in a smoky cloud that drifts on the wind. In tropical forests, the massive bracket fungi cling to tree trunks like shelves, some growing wide enough to serve as a natural seat. In folklore, these giant mushrooms inspired awe, as they seemed less like plants and more like creatures of myth. To stand before one of these enormous fungi is to be reminded that mushrooms are not always small or fleeting. They can be monumental, sprawling, and enduring, their size rivaling that of the creatures that walk among them. A kingdom of extremes. Fungi stretch from the nearly invisible to the astonishingly vast. The smell of truffles can drive animals wild. Truffles, the prized underground mushrooms, emit an aroma so powerful it captivates both humans and animals. Their scent contains compounds similar to pheromones, the chemical signals many creatures use for communication. For pigs, especially, the smell of truffles can be irresistible, so much so that farmers once relied on pigs to sniff them out. Dogs are now preferred as they can detect the scent without devouring the find. Humans, too, are enchanted. Truffles are among the most expensive foods in the world, valued for their musky, earthy, intoxicating aroma. The scent wafts through soil, drawing animals that dig them up, unknowingly helping spread the spores. This curious strategy has allowed truffles to flourish underground, where they cannot release spores into the air. Instead, they rely on a lure, a perfume so compelling that entire species are driven to seek them out. Mushrooms help trees talk to each other. Deep in the forest, trees are not silent. They trade sugars, water, and even warning signals with one another, and fungi make it possible. Mycorrhizal fungi form partnerships with tree roots, extending their mycelial networks deep into the soil. Through these connections, trees can share resources. A shaded tree, for example, may receive extra sugars from its sunlit neighbors, passed along by the fungal threads. If pests or disease threaten, chemical signals can spread underground, alerting other trees to prepare defenses. This hidden conversation is sometimes called the wood wide web. Without fungi, forests would be far less cooperative, and many young trees would never survive. The next time you walk through a forest, imagine the roots below you not as separate systems, but as parts of a great, interconnected mind, a quiet network where mushrooms act as the translators between giants. The wood wide web connects entire forests. The idea of the wood wide web has captured the imagination of scientists and storytellers alike. It is not just individual trees that connect through fungi, but entire forests. A single mycelial network may link dozens, even hundreds of trees, binding them into one interdependent community. Old mother trees can feed their seedlings through this web, nurturing the next generation. Dying trees can even pass on their remaining resources, leaving behind a kind of legacy through the network. This underground web allows a forest to act less like a collection of individuals and more like a single organism, responsive and alive. What we see above ground, trunks, branches, and leaves, is only half the story. Below, in the dark soil, the fungal kingdom is weaving a web as complex as the neural networks in our own brains, sustaining the forest's hidden unity. Mushrooms can store carbon underground for centuries. One of the quietest but most important roles fungi play is in carbon storage. Through their partnerships with plants, fungi help move carbon from the air into the soil, locking it away in underground networks of mycelium. Some of this carbon can remain buried for centuries, safely stored out of the atmosphere. In this way, fungi are allies in stabilizing Earth's climate, preventing excess carbon dioxide from heating the planet too quickly. Forests owe much of their role as carbon sinks to the fungal webs that keep nutrients flowing and carbon stored. Even when fungi decompose matter, they regulate how quickly carbon is released back into the air. In a time when climate change dominates human concern, the humble mushroom may prove to be one of Earth's most effective guardians, working silently beneath the soil to keep balance in the global cycle. Some mushrooms grow only on animal dung. As strange as it sounds, certain mushrooms thrive in places most of us would avoid, the dung of animals. Species like the Copronypsis, sometimes called inky caps, sprout directly from manure. This may seem unappealing, but it's an ingenious strategy. Dung is rich in nutrients, already broken down by the animal's digestive system, and fungi are perfectly equipped to recycle what remains. In doing so, they complete the cycle of life, turning waste into fertile soil once again. Some of these mushrooms even launch their spores with incredible force, shooting them far enough to escape the shadow of the dung pile and land on fresh grass, where grazing animals may eat them, beginning the cycle anew. What seems unpleasant to us is, to fungi, opportunity. In their world, nothing is wasted, not even the most unlikely materials of life. Others appear only after a forest fire. Some mushrooms wait patiently for destruction before making their entrance. These are known as pyrophilous fungi, lovers of fire. They remain hidden in the soil until flames sweep through a forest, clearing away vegetation and leaving behind ash. Then, almost magically, mushrooms like the morel begin to sprout in great numbers. Fire alters the chemistry of the soil, creating conditions that these fungi require to thrive. For foragers, burned forests can become treasure troves of morels, prized for their honeycombed caps and rich, earthy flavor. But beyond human fascination, these fire-following fungi play a vital ecological role. They recycle nutrients quickly, preparing the ground for new growth and helping forests recover from devastation. Where flames have consumed, mushrooms rise, transforming loss into the beginning of renewal. In their quiet way, they are the first responders of the forest, turning destruction into fertile ground for rebirth. Certain mushrooms contain natural antibiotics. Long before modern medicine, fungi were already chemists, producing compounds to defend themselves against bacteria and other microbes. Many of these compounds turned out to be useful for humans as well. Penicillin, the first widely used antibiotic, was famously discovered in a mold, a close fungal relative of mushrooms. But mushrooms themselves contain antimicrobial substances too, some of which are being studied as potential treatments for infections. In the wild, these compounds help fungi survive in environments teeming with competitors. For us, they are reminders that solutions to human problems often lie quietly in nature, waiting to be noticed. The next time you see a mushroom growing from a fallen log, imagine it as a tiny laboratory, crafting chemicals not just for its own survival, but perhaps for the healing of creatures far beyond its forest home. Without fungi, bread and beer wouldn't exist. The everyday miracle of bread rising in the oven or beer foaming in a glass is made possible by fungi. Yeast, a single-celled relative of mushrooms, transforms sugars into alcohol and carbon dioxide. This process not only gives bread its fluffy texture, but also produces the bubbles in beer and champagne. Without fungi, human cuisine would look entirely different. No loaves of warm bread, no wine, no frothy ales. Archaeologists have found evidence of fermentation stretching back thousands of years, showing that humans and fungi have been partners since the dawn of civilization. In a sense, fungi have shaped culture as much as they have shaped forests, influencing rituals, economies, and celebrations. When you tear open a loaf of bread or sip a drink, you are tasting the invisible work of fungi, harnessed for joy and nourishment since time immemorial. The yeast used in baking is a fungus. It's easy to forget that the yeast sprinkled into dough or mixed into a brewer's vat is alive. These microscopic fungi feed on sugar, multiplying quickly and releasing gases that puff up dough or create fizz. Though tiny, yeast are ancient companions of humanity. They were likely first discovered by accident, when wild yeast drifting in the air landed on crushed fruit or damp grains, sparking fermentation. Over time, people learned to cultivate and control yeast, turning them into the unseen workers behind kitchens and breweries. Modern yeast strains are carefully bred, but they remain members of the fungal kingdom, cousins of the mushrooms that sprout in forests. In every loaf of bread, every bottle of wine, there is a quiet fungal story. Billions of cells working together, unseen but essential, turning sweetness into substance and reminding us of life's hidden connections. Some mushrooms can bleed red liquid. In certain forests, you might stumble upon a mushroom that looks as though it has been wounded. Drops of bright red liquid bead on its cap, resembling blood. One of the most famous is Hydnellum pecii, sometimes called the bleeding tooth fungus. Despite its unsettling appearance, the red fluid is not blood, but a sap-like exudate rich in pigments and compounds. The purpose is still debated. It may help the fungus regulate moisture or fend off microbes. To encounter such a mushroom feels uncanny, as though nature is imitating the familiar in strange and eerie ways. These bleeding fungi remind us that the forest holds secrets designed not for human eyes, but for the survival of the organisms themselves. We are only accidental witnesses, wandering through a world where even mushrooms can drip crimson jewels in the moss. Others smell exactly like rotting flesh. Some mushrooms survive not by looking beautiful, but by smelling revolting. Known as stinkhorns, these fungi emit odors nearly identical to decaying meat. The smell attracts flies and beetles, which land on the mushroom and unwittingly carry away its spores. It is an ingenious strategy, turning repulsion into dispersal. To humans, the stench can be overwhelming, yet these mushrooms are masters of manipulation, deceiving insects into doing their bidding. In some cultures, stinkhorns are associated with spirits or omens, their sudden appearance and foul aroma linked to superstition. But in reality, they are simply clever survivors, evolving to use smell as a lure. In the stillness of a forest, the sudden whiff of decay may not signal death at all, but rather the strange life of a mushroom, playing tricks on the senses of every creature that passes. Fungi can create entire underground cities. When mycelium spreads beneath the soil, it doesn't just form random threads. It builds complex, layered networks that resemble bustling underground cities. Highways of hyphae branch and reconnect, creating channels for nutrients to flow. Some areas act like marketplaces, where resources are exchanged with plants. Others serve as storage vaults, holding reserves for lean times. Scientists using advanced imaging have found that these networks display remarkable efficiency, optimizing pathways much like human-designed infrastructure. In a way, fungi are engineers, constructing hidden architectures that rival our own cities in design. While we pave roads and build skyscrapers above ground, the fungal kingdom is quietly weaving intricate worlds below, where billions of organisms cooperate and thrive. The soil beneath our feet is not empty, but alive with a society of threads, a metropolis without walls, glowing softly with the pulse of life. Some mushrooms can change color when touched. In the fungal world, appearances can be deceiving. Some mushrooms shift their colors when handled, bruised, or cut. One striking example is the blue-staining bolete, which turns a vivid cobalt blue when its flesh is exposed to air. This color change happens because of chemical reactions between compounds in the mushroom and oxygen. For foragers, the transformation can be a helpful identification clue, though not always an indicator of edibility. The effect is mesmerizing. A plain-looking mushroom instantly transforms into something dazzling, as though revealing a hidden side of itself. In folklore, mushrooms that changed color were thought to be enchanted or magical, carrying secret powers. To touch one today is to feel that same wonder, that in the simple act of contact, the forest reveals a trick. a fleeting glimpse of chemistry disguised as sorcery. There are mushrooms that smell like maple syrup. Not all mushroom scents are unpleasant. Some release fragrances so delightful they seem designed for human appreciation. The candy-cap mushroom, for example, carries a scent almost identical to maple syrup. When dried, the aroma intensifies, filling rooms with the sweetness of pancakes and sugar. Chefs use these mushrooms to flavor desserts, cookies, and ice creams, transforming a forest find into culinary magic. The smell comes from compounds called lactones, which trick our senses into associating the mushroom with sweetness. To stumble upon one in the wild is like finding a secret kitchen hidden under the trees. It's a reminder that fungi are masters of chemistry, crafting scents that can repel, attract, or simply astonish. From the stench of rot to the perfume of maple syrup, mushrooms play an invisible symphony of smells, each note written in molecules we are only beginning to understand. Some mushrooms smell like coconut or almonds. As varied as flowers in their scents, mushrooms can smell like a surprising range of familiar foods. Certain species carry aromas of coconut, almonds, or even marzipan. The almond-scented agaricus, for instance, has a fragrance so close to the nut that some foragers rely on it as a key identification marker. Coconut-scented russulas, meanwhile, seem to echo tropical sweetness despite sprouting from temperate forest floors. These scents are created by volatile compounds that waft into the air, attracting animals or simply deterring others. For humans, they become delightful curiosities, proof that fungi play with chemistry in ways that overlap with our kitchens and memories. To lean close to a mushroom and catch the smell of dessert or fruit is to feel, just for a moment, that the forest itself is dreaming of flavors, weaving familiar comforts into its strange and secret growths. Mushrooms are packed with vitamin D. Few foods naturally contain vitamin D, yet mushrooms have a secret. They can make their own. Like us, they produce vitamin D when exposed to sunlight. When ultraviolet light touches a mushroom's skin, it converts compounds inside into this essential nutrient. For humans, vitamin D strengthens bones, supports the immune system, and balances mood. A handful of sun-dried mushrooms can contain as much vitamin D as a supplement. Some cultures even place freshly harvested mushrooms in the sun before eating them, boosting their nutritional power. It's astonishing to think that mushrooms and humans share this ability, both relying on the same chemistry of light. In the Doom Forest, mushrooms may seem far removed from the sun, but when touched by its rays, they store its energy, becoming not only food, but a bridge between light, soil, and life. Certain mushrooms contain natural toxins that glow. In some fungi, poison and beauty intertwine. There are species whose toxins not only protect them, but also give them the power to glow. These bioluminescent mushrooms emit soft green or blue light, created by chemical reactions involving luciferin and luciferase. Scientists believe the glow may serve multiple purposes: deterring predators, luring insects, or signaling to other organisms. The eerie shine is most visible at night, when patches of forest floor seem to shimmer with a faint, otherworldly glow. To stumble upon such a sight is both enchanting and unsettling. Mushrooms that are dangerous to touch, yet luminous, as if lit from within. In folklore, glowing fungi were taken as signs of spirits or omens, their ghostly light hinting at the presence of the supernatural. Science reveals the chemistry, but the wonder remains. Life finding ways to turn defense into radiance. The death-cap mushroom has no antidote. Among the most feared fungi on Earth is the death-cap, Amanita phalloides. It looks deceptively ordinary: pale green cap, wide stalk, a mushroom you might easily mistake for edible. But hidden within is a toxin called amatoxin, one of the deadliest substances known. Just half a cap can be enough to kill an adult human. Worse still, symptoms may not appear for hours, lulling victims into false security before liver and kidney damage begins. No antidote exists. Hospitals can provide supportive care, sometimes even liver transplants, but survival is uncertain. This mushroom alone has been responsible for countless accidental deaths throughout history. The fact that such danger hides in such a fragile form reminds us of nature's indifference. Beauty and terror coexist in the forest, and mushrooms, so often healers and recyclers, can sometimes carry within them a lethal secret written in chemistry. A mushroom once saved the world from a cholera outbreak. In the 19th century, cholera was a terrifying disease sweeping through Europe, Asia, and beyond. People were desperate for cures, and one unlikely hero came from the fungal kingdom. A fungus called Penicillium glaucum, related to the one that gave us penicillin, was found to stop the cholera bacterium in its tracks. The discovery wasn't fully understood at the time, but it offered early evidence of fungi's medicinal powers. Later, the broader discovery of antibiotics confirmed what this mushroom had hinted all along. Fungi carry compounds, but can change the course of human history. Imagine entire cities trembling under the fear of disease, only to find relief in the unassuming growth of a mold. That moment was a quiet foreshadowing of the antibiotic revolution to come. Proof that mushrooms and their relatives can stand between humanity and its most dangerous foes. Fungi can remember past conditions. It may sound strange, but fungi have been shown to remember experiences. In laboratory experiments, researchers noticed that fungal networks exposed to certain environmental changes, like shifts in temperature, moisture, or nutrient supply, could respond differently when those can depower. Conditions returned. The mycelium seemed to learn from its past, adjusting more quickly the second time around. This memory isn't like human thought, but it is a form of biological recall encoded in the fungal threads. Such adaptability may explain why fungi are among the most resilient life forms on Earth. They respond to patterns, remember, and adapt. To walk through a forest is to walk through a landscape alive not only with growth but with memory. Networks of fungi recalling storms, droughts, and fires, silently adjusting for the survival of all. It's as if the soil itself remembers, carried in the hidden threads beneath our feet. Some mushrooms can survive freezing solid. In the depths of winter, when the ground is locked in ice, you might think mushrooms would vanish. Yet certain species are astonishingly resistant to cold. Some can freeze solid, their water turn to ice crystals, and still revive once conditions improve. Others continue to fruit beneath snow, pushing small caps through frost as if untouched by the season. Their resilience lies in antifreeze-like compounds that protect their cells from damage. For creatures that seem so fragile, this toughness is extraordinary. It means mushrooms can colonize environments as harsh as tundra and alpine peaks. To stumble upon a mushroom sprouting through snow is to see defiance in its purest form. Life quietly enduring in conditions that would stop most plants. They are reminders that even in the coldest, bleakest places, hidden kingdoms continue their slow and steady work of survival. Mushrooms have been used in traditional medicine for millennia. Across cultures and centuries, mushrooms have been revered as healers. In traditional Chinese medicine, reishi mushrooms are called the mushroom of immortality, believed to enhance longevity and vitality. In Japan, shiitake mushrooms were once reserved for nobility as a tonic for health. Indigenous peoples in Siberia, North America, and Africa all developed their own mushroom medicines, from teas to poultices, using fungi to treat wounds, fevers, and fatigue. Modern science is now catching up, finding compounds in mushrooms with immune-boosting, anti-inflammatory, and even anti-cancer properties. What ancient healers sensed through experience, laboratories now confirm with microscopes and assays. When you sip mushroom tea or hear of medicinal extracts, you're part of a lineage stretching back thousands of years, a testament to the deep bond between humans and fungi, a bond woven from both necessity and reverence. Lion's mane mushroom can regrow nerve cells in animals. The lion's mane mushroom, with its cascading icicle-like spines, is not only beautiful, but also powerful. Studies in animals have shown that compounds within lion's mane can stimulate the growth of nerve cells. These compounds, called hericenols and erinacines, encourage the production of nerve growth factor, a molecule crucial for repairing and maintaining neurons. This discovery has sparked intense interest in lion's mane as a potential therapy for neurodegenerative diseases like Alzheimer's and Parkinson's. For centuries, it has been used in traditional Asian medicine as a brain tonic, and now modern science is uncovering why. Imagine a mushroom, soft and white like a frozen waterfall, carrying inside it the potential to heal the most intricate networks of the human mind. It is a reminder that the solutions to our deepest medical challenges may still be hiding in the quiet corners of the forest. Some mushrooms release their spores in a puff of smoke. Puffball mushrooms hold a special kind of magic. When mature, their spherical bodies fill with millions of spores, waiting for the right moment to disperse. A raindrop, a paw, or even a curious human touch can trigger the release, sending a smoky burst into the air. What looks like smoke is actually a shimmering cloud of spores, each a tiny capsule of possibility, drifting into the wind. For children and foragers, puffballs often become a source of delight, a living fireworks display in miniature. But beyond the wonder, this strategy is deeply effective. In a single puff, trillions of spores may be carried away, ensuring the continuation of the species. To see one erupt in a cloud is to witness life's persistence in action, disguised as a fleeting trick of smoke on the forest floor. Fungi help decompose every fallen leaf in a forest. When autumn carpets the ground with leaves, fungi begin their patient work. Without them, the forest would choke beneath layers of debris. Fungi secrete powerful enzymes that break down cellulose and lignin, the tough materials that give wood and leaves their structure. What seems like slow decay is actually an elegant recycling system. The nutrients locked within those leaves are released back into the soil, ready to feed new growth in spring. Every flower that blooms, every blade of grass that rises, owes its life in part to this process. Fungi are the unseen caretakers of the forest, ensuring that nothing is wasted, that death becomes life again. To stroll through autumn woods is to walk across an unseen economy, powered by mushrooms, where every fallen leaf becomes part of a cycle older than time itself. Without fungi, life on Earth would drown in debris. Every year, billions of leaves fall, branches snap, trees topple, and animals perish. Without fungi, all this organic matter would pile endlessly, layer upon layer, until the planet was buried in its own debris. Fungi are the great recyclers, secreting enzymes that dismantle the toughest molecules in wood, leaves, and bone. They turn what seems solid and final into soil, nutrients, and air, feeding the next generation of life. If fungi were to vanish, forests would suffocate beneath their own weight, and the cycles of renewal would grind to a halt. Every step you take on a forest floor is possible only because countless fungal threads have worked tirelessly to clear the way. dissolving yesterday's remains into tomorrow's growth. In silence and patience, fungi keep the earth breathable, livable, and ever-renewing, the unseen caretakers preventing the world from drowning in its past. Some mushrooms are invisible until nightfall. In daylight, certain mushrooms vanish into their surroundings, blending with bark, leaves, and soil. But when darkness falls, they reveal their secret. Bioluminescent fungi glow softly in hues of green, blue, or yellow, emerging from the shadows like ghostly lamps. To stumble upon one in a night forest is to feel you've entered another realm, where mushrooms light their own way. The glow comes from a delicate chemical dance within their cells, similar to the reaction that makes fireflies shine. Some species glow only at night, conserving energy during the day, as though performing solely for the darkness. For centuries, these glowing fungi inspired myths of forest spirits, guiding or tricking travelers under the moon. Today, they still stir the imagination, proving that the forest has its own lanterns, switched on only when the stars come out. Fungi can farm algae to make lichens. Lichens, those colorful crusts and frills that cling to rocks and trees, are not single organisms but partnerships. They are fungi that have learned to farm algae or cyanobacteria. The fungus provides structure, protection, and moisture, while the algae supply food through photosynthesis. Together, they create entirely new forms of life, able to survive in extreme places where neither could thrive alone. Arctic tundras, bare cliffs, deserts, even outer space. Lichens are some of Earth's oldest and toughest colonizers, preparing rock to become soil, painting the world with patches of green, yellow, and orange. In essence, fungi are not just scavengers but farmers, cultivating their partners in one of nature's earliest examples of cooperation. Each lichen is a quiet story of partnership, proof that survival often comes not from competition, but from working together across kingdoms of life. Certain mushrooms are edible only once cooked. Not all mushrooms can be eaten raw, even if they aren't poisonous. Some contain mild toxins or indigestible compounds that are neutralized only by cooking. Morels, highly prized by chefs, are one such example. Raw, they can cause stomach upset, but once sautéed or roasted, they transform into delicacies with nutty, earthy flavors. Others, like shiitakes, release richer aromas and nutrients only when heat unlocks their chemistry. It's as though fire completes their story, turning potential harm into nourishment. For foragers, this knowledge has been passed down for generations. The right preparation turns danger into delight. The transformation is almost alchemical, the simple act of cooking converting something untrustworthy into something nourishing. Mushrooms remind us that food is not always straightforward. Sometimes it requires respect, patience, and ritual to unlock what lies hidden within. Some mushrooms are so bitter they cannot be eaten. Not every mushroom aspires to be eaten. Some defend themselves with flavors so intensely bitter that even the hungriest animal will spit them out. The bitter bolete, for instance, looks almost identical to edible relatives, but delivers a taste so acrid it can ruin a dish with just a bite. These defensive compounds are nature's way of discouraging predators without resorting to toxins. To humans, bitterness is often a warning, a sensory alarm that tells us to stop. In the fungal kingdom, it is one more tool in the arsenal of survival. Yet even these unpalatable mushrooms contribute to ecosystems, recycling matter and nourishing soils. They remind us that not everything in the forest is meant for us. The taste itself is part of the conversation between species, a quiet push and pull that determines who eats and who is left alone. Fungi can create natural hallucinogens. Among the most famous and controversial mushrooms are those that produce hallucinogenic compounds, such as psilocybin. These chemicals can profoundly alter human perception, creating visions, distortions of time, and a sense of connection beyond the self. For centuries, such mushrooms were used in spiritual and shamanic rituals, believed to open doorways to the divine. In recent years, scientists have begun revisiting these fungi with renewed interest, studying their potential to treat depression, anxiety, and addiction. The fact that a mushroom can change consciousness so deeply is astonishing. It suggests that fungi not only recycle the forest, but can also rewire the human mind. Whether seen as sacred, dangerous, or therapeutic, these mushrooms sit at the intersection of biology and mystery, carrying within their fragile caps the power to shift reality itself. Ancient cave paintings may depict mushroom use. In caves scattered across Spain and Algeria, prehistoric paintings show human figures holding objects that resemble mushrooms. Some scholars interpret these as evidence that early humans not only gathered mushrooms for food, but also for spiritual experiences. The images show dancing figures, bursts of color, and patterns that echo the kinds of visions hallucinogenic mushrooms can evoke. While we can't be certain, the possibility that humans were exploring fungal states of mind tens of thousands of years ago is tantalizing. It suggests that mushrooms have been shaping culture, ritual, and imagination since the dawn of art itself. To imagine ancient people huddled around firelight, painting mushrooms on cave walls as symbols of journeys into the unseen, is to feel a deep connection, across millennia, to the ways fungi have always inspired both survival and story. Mushrooms can be used to make biodegradable packaging. In a world struggling with plastic waste, fungi may offer a solution. Mycelium can be grown into molds to form lightweight, durable packaging materials. Once dried, the material resembles polystyrene foam, but is completely biodegradable. Companies are already experimenting with mushroom packaging to replace styrofoam in shipping boxes, electronics, and even furniture cushioning. After use, it can be composted, returning harmlessly to the soil. The process uses agricultural waste as food for the mycelium, meaning the raw ingredients are abundant and renewable. It's astonishing to think that the same organism sprouting mushrooms in the forest could one day cushion your parcels or protect fragile goods, leaving behind no pollution. Where plastic clings to the earth for centuries, fungi promise a cycle of creation and return, offering hope that packaging itself can one day become part of the natural flow of life. Some mycelium acts as a natural fire retardant. Researchers have discovered that certain types of mycelium, when grown into materials, resist flames naturally. Unlike plastics or wood, which ignite and release toxic smoke, mycelium composites char and smolder without producing dangerous gases. This makes them promising as eco-friendly insulation, furniture, and building materials. Imagine walls lined with fungal networks, strong and safe, protecting homes not only from the elements, but from fire. The secret lies in the chitin and polysaccharides of the fungal cell walls, which resist burning. Nature, through fungi, has engineered a material humans are only beginning to appreciate. Mycelium fireproofing could transform construction, making buildings both safer and greener. To realize that the same hidden threads that stitch together a forest floor could also shield a house from flames is a reminder of fungi's versatility, a quiet kingdom offering tools for the future. Mushrooms could replace leather with mica leather. Leather has long been valued for its strength and flexibility, but its production is resource-intensive and environmentally costly. Enter mica leather, a material grown from fungal mycelium. It can be cultivated in sheets, tanned and finished to mimic the look and feel of traditional leather. The result is durable, breathable, and entirely biodegradable. Designers are already crafting shoes, handbags, and furniture from this innovative material. Unlike animal hides, which take months or years to produce, mica leather can be grown in weeks, with far less water and no cruelty involved. Its texture can be adjusted soft and suede-like, or smooth and glossy. To think that the same network that forms mushrooms can also become a jacket or a chair is almost surreal. Fungi are not only healers and recyclers, but inventors, offering humanity materials that bridge beauty, ethics, and sustainability. Certain mushrooms contain compounds that melt ice. In forests where winters are long and hard, some mushrooms carry secrets that let them endure. Certain species produce antifreeze-like proteins and sugars that keep their cells safe even when the air freezes. These compounds lower the freezing point of water, preventing sharp ice crystals from forming and tearing delicate tissues apart. In the soil, this allows fungi to keep breaking down leaves and wood when most organisms lie dormant. More astonishing still, these molecules can sometimes seep into the environment, loosening the grip of frost around the mushroom. Researchers are studying these natural antifreezes as models for safer ways to protect crops from frost or de-ice roads without harsh chemicals. It is humbling to imagine a tiny mushroom no bigger than your palm, quietly reshaping its frozen surroundings, reminding us that resilience is often found in the smallest, softest corners of life. Fungi can extract minerals from rocks. Though they lack tools or muscles, fungi are extraordinary miners. Some species release organic acids that slowly dissolve rock, unlocking nutrients like calcium, magnesium, and potassium. In doing so, they transform lifeless stone into fertile soil, creating foundations for forests and fields. This process may have begun more than 1 billion years ago, when fungi first crept across bare landscapes, paving the way for plants to colonize land. Even today, lichens, partnerships between fungi and algae, etch their way across cliffs and gravestones, tiny but relentless. Over centuries, their work reshapes entire mountainsides. Scientists now imagine biomining technologies inspired by these fungi, harvesting rare elements with far less damage than human machines cause. To stand before a rocky outcrop and realize that it is being quietly eaten, molecule by molecule, by unseen fungal threads, is to see patience itself turned into power. Some mushrooms thrive on radioactive waste. In places where human life falters, mushrooms sometimes flourish. At Chernobyl and other contaminated sites, scientists have found fungi growing in rubble, bathed with radiation. These fungi contain melanin, the same pigment in our skin, but here it appears to serve another purpose. Instead of shielding alone, it seems to transform radiation into energy, a strange process dubbed radiosynthesis. Imagine mushrooms performing a kind of photosynthesis, not with sunlight but with radiation we consider deadly. These discoveries hint at extraordinary possibilities. Fungi that could help clean radioactive waste, or shield astronauts traveling through the harshness of deep space. In the ruins of disaster zones, mushrooms remind us that life adapts even to the unthinkable, twisting danger into nourishment. What for us is poison becomes, for them, fuel, proof of nature's astonishing ability to survive, where survival seems impossible. Mushrooms may have helped plants colonize land. When the first green plants left the oceans to settle on land, they faced a barren world. Bare rock, no soil, and few nutrients. But they were not alone. Fossils show that fungi were already there, ready to partner with them. These early alliances allowed plants to draw nutrients from rock, shared by fungal networks, in exchange for sugars. Over time, This collaboration created the first thin soils, making it possible for forests and grasslands to emerge. Without fungi, plants might have never taken root on land, and Earth might still be silent, barren, and grey. Every tree, every meadow, every blade of grass carries the legacy of this partnership. When you walk across a field today, you are walking on ground prepared by fungi hundreds of millions of years ago, a silent debt written into the very fabric of our planet's living green. Some fungi form partnerships with coral reefs. Though we think of mushrooms as forest dwellers, fungi also make their homes in the sea. Marine fungi have been discovered living alongside corals, weaving unseen threads into the vibrant architecture of reefs. These partnerships may help regulate nutrients, protect corals from pathogens, or stabilize fragile reef ecosystems. Though little studied compared to their terrestrial cousins, marine fungi could be crucial to the survival of coral reefs under the stresses of climate change. To picture fungi drifting among coral polyps is to realize that the fungal kingdom is not limited to soil and trees. It stretches into salt water, stitching together life in hidden ways. If corals are the architects of reefs, fungi may be their caretakers, helping them endure. Even beneath the waves, mushrooms and their kin remind us that life is never solitary. It is always built upon partnerships. Mushrooms can reproduce both sexually and asexually. Fungi are masters of flexibility. They can release spores asexually, producing countless genetic copies in an efficient burst of reproduction. This strategy allows them to colonize quickly, spreading through soil and air with astonishing reach. But fungi also reproduce sexually, exchanging genetic material with others to create variation. This gives them the adaptability needed to face changing conditions, pests, or new environments. Some species even switch between methods depending on their circumstances, maximizing their survival chances. Imagine an organism with two entirely different strategies for making more of itself, one for speed, one for resilience. It is a level of versatility few life forms possess. Each mushroom you see may be the outcome of a cloning lineage or a genetic mix, a visible reminder that fungi hold within them not just one way of being, but many. Some species have over 20, 000 different genders. In the fungal world, reproduction takes diversity to astonishing extremes. Some species have tens of thousands of mating types, the equivalent of genders. The split-gill mushroom, for example, may have more than 23, 000. These are not genders in the human sense, but compatibility codes written into their DNA. The effect is the same. Nearly any two individuals can mate successfully, maximizing opportunities for reproduction. This system prevents inbreeding and encourages a dazzling variety of genetic combinations, ensuring resilience across generations. Where humans imagine gender as simple and binary, fungi explode the concept into tens of thousands of possibilities. To consider a mushroom's mating system is to glimpse the creativity of evolution itself, reminding us that life is not bound to our categories. For fungi, diversity is not the exception, it is the rule, woven into their very being. A single puffball can release trillions of spores. When a puffball reaches maturity, it transforms into a sphere filled with a fine, powdery mass of spores. A raindrop, a falling twig, or the touch of a curious hand can trigger the release, sending a smoky cloud into the air. What seems like a puff of dust is actually a storm of microscopic lives. A single large puffball can release trillions of spores, more than the number of people who have ever lived. Most spores will drift away, landing in places too dry or barren to grow. Yet a few will find the right conditions and begin new colonies, continuing the lineage. This strategy is about numbers. overwhelming chance with sheer abundance. Watching a puffball erupt is like watching the forest breathe, a moment of release where invisibility becomes visible and possibility scatters into the wind by the millions. Spores can be found floating high above cities. The fungal kingdom is not confined to the forest floor. Spores rise on air currents, carried higher and higher, until they drift far above rooftops and skyscrapers. Studies have found them thousands of feet above cities, mingling with dust and pollen in the atmosphere. Some are even swept into clouds, falling later with raindrops onto distant landscapes. Every breath we take in a city contains traces of spores, fragments of distant forests, gardens, and soils. Even surrounded by concrete, we are still connected to the hidden networks of fungi. In a way, the air itself is a bridge between wild and urban, carrying spores as constant messengers. The next time you walk down a busy street, remember that the fungal kingdom is with you, drifting invisibly overhead, linking your breath to ecosystems you may never see. Mushrooms may influence global weather. Invisible though they are, spores may shape something as vast as the weather. Tiny and abundant, they rise into the atmosphere, where they act as seeds for water droplets. Around these particles, clouds can form. In this way, fungi may help determine when and where rain falls, participating quietly in Earth's climate cycles. Forests may not only recycle nutrients underground, but also call rain from the sky, sending spores aloft to coax moisture into clouds. The idea is still under study, but it suggests that mushrooms influence more than soil. They may reach into the very patterns of the atmosphere. Imagine raindrops forming around spores released in a distant forest, falling days later across fields and rivers. Fungi blur the line between ground and sky, reminding us that life does not stop at borders, but flows upward, outward, and everywhere. Certain fungi can absorb heavy metals. In soils polluted by human industry, fungi often step forward as silent healers. Certain mushrooms have an extraordinary ability to absorb and lock away heavy metals like lead, mercury, and cadmium. Their mycelial threads act like sponges, drawing toxins from the environment and concentrating them inside their fruiting bodies. This process, called mycelial, offers hope for cleaning contaminated land without digging, burning, or chemicals. Though the mushrooms themselves become unsafe to eat, they have already served their purpose, turning poisoned ground into fertile soil again. Imagine a ruined landscape, littered with waste, where mushrooms sprout defiantly, working as living filters. They are nature's alchemists, transmuting danger into something contained. In their quiet labor, fungi reveal a blueprint for resilience, that even in the most damaged corners of the earth, healing can begin. Not with machines, but with the silent patience of threads in the soil. Mushrooms can be used to clean up oil spills. When oil spills into soil or water, the damage can linger for decades. But fungi may offer an elegant solution. Certain mushrooms are capable of breaking down hydrocarbons, the very molecules that make up oil, into harmless substances. Their mycelium secretes enzymes that dismantle toxic sludge, transforming black slicks into fertile earth where plants can grow again. In experiments, areas treated with fungi have turned from oily wastelands into blooming fields within weeks. Birds and insects return, and the land breathes once more. This technique, part of the broader field of mycomediation, suggests mushrooms could play a role in healing some of humanity's greatest environmental disasters. Picture an oil-soaked shore slowly turning green again, not through human intervention alone, but with the help of mushrooms spreading their threads through the poisoned ground. Nature, it seems, holds the antidote within the very organisms we often overlook. Some mushrooms taste like chocolate. Mushrooms are usually linked with earthy, savory flavors, but some species surprise with sweetness. A few rare fungi produce aromas and tastes reminiscent of chocolate or cocoa. Scientists believe these flavors come from unique aromatic compounds, molecules that mimic the same sensations chocolate creates on our tongues. Though not as common as truffles or candy caps, these chocolate-like mushrooms remind us how diverse the fungal palette can be. Imagine walking through a forest, expecting damp earth and leaf mold, only to catch a whiff of something warm and sweet, like a bakery in the middle of the woods. For chefs, these mushrooms open strange possibilities, desserts flavored not with cacao beans, but with forest fungi. It's another way mushrooms blur the boundaries of expectation, offering surprises not only in their shapes and colors, but in tastes that can feel like an echo of human comforts. Others glow green like lanterns. In tropical forests, certain mushrooms cast an eerie glow that can stop you in your tracks. These bioluminescent fungi shine with a greenish light, sometimes bright enough to illuminate surrounding leaves. The glow is caused by a chemical reaction involving luciferin and luciferase, similar to the process fireflies use. Scientists believe the light may help attract insects at night, carrying spores to new places. To encounter them in the dark is to feel as though the forest itself has lit lanterns on the ground, glowing softly in the undergrowth. For centuries, travelers told stories of fairy fire and foxfire, mysterious lights that shimmered from rotting wood. Today, we know they are mushrooms, revealing their hidden radiance. They remind us that even in darkness, life finds ways to shine, creating small green beacons in the night to carry its story forward. Mushrooms once grew as tall as trees. Hundreds of millions of years ago, Earth's landscapes looked very different. Long before towering pines or oaks, massive fungi called prototexites dominated the land. These strange organisms grew up to 30 feet tall, making them the tallest life forms of their time. Rising like pillars, they dotted ancient landscapes in a world where insects had only just begun to take flight. Fossils suggest these giants may have looked like enormous tree trunks, yet they were neither plant nor tree, but fungi. Imagine a primeval plain with towering fungal spires, standing solitary against a barren horizon. They prepared the land for the forests to come, breaking down rock, building soil, and shaping ecosystems. Today, mushrooms are mostly small and fleeting, but their ancestors once ruled the earth, guardians of a forgotten age when fungi, not trees, were the giants of the land. Some fungi can survive complete desiccation. Water is usually considered the essence of life, but some fungi can endure even when every drop is stripped away. Certain desert fungi and lichens can survive complete desiccation, drying until they are seemingly lifeless. Yet when moisture returns, they awaken, continuing growth as if nothing happened. This extraordinary resilience comes from special sugars and proteins that protect their cells from collapsing during drought. It allows them to colonize the harshest deserts and rocky outcrops, places where few organisms can endure. Scientists study these fungi for clues about how life might survive on Mars or other arid planets. Imagine a tiny thread of fungus, brittle and dormant for years, springing back to life with the touch of rain. In their quiet endurance, these organisms show us that survival sometimes means not fighting conditions, but waiting, perfectly still, until the moment is right. Mushrooms have been sent into space experiments. The strange resilience of fungi has made them subjects of space research. Scientists have sent mushrooms and fungal spores aboard spacecraft to test their survival in microgravity and cosmic radiation. To their amazement, many fungi not only survived, but continued to grow. Some species even seemed to adapt, altering their chemistry in response to the extreme environment. Such studies hint that fungi could play a role in future space missions, perhaps recycling waste, producing food, or even shielding astronauts from radiation. There is even speculation that hardy spores might survive interplanetary travel, drifting through space to seed new worlds. Whether or not this is true, mushrooms in orbit remind us that life is astonishingly adaptable. A mushroom that can sprout in the vacuum of space stretches our imagination of where life can go, suggesting that Earth's hidden kingdom may have cosmic potential. Certain fungi help crops resist disease. Beneath fields of wheat, corn, or rice, invisible allies are at work. Mycorrhizal fungi, which live in partnership with plant roots, not only provide nutrients but also bolster plants against disease. By stimulating a plant's immune system, fungi make crops more resistant to pests and pathogens. In some cases, they even outcompete harmful microbes directly, blocking them from attacking roots. Farmers are beginning to harness this ancient partnership, using fungal inoculants to reduce reliance on chemical pesticides. Imagine crops strengthened not by sprays but by quiet, underground allies, weaving protective webs around their roots. These partnerships are reminders that agriculture is not a battle against nature, but a collaboration with it. Just as forests thrive on fungal networks, farms of the future may find their greatest resilience not in chemicals, but in the same humble fungi that have been nourishing plants for millions of years. Mushrooms are used to produce life-saving drugs. Beyond antibiotics, mushrooms and their relatives are chemical treasure houses. Compounds derived from fungi are used to lower cholesterol, suppress immune rejection in organ transplants, and even fight cancer. Lovastatin, a drug that revolutionized heart medicine, comes from fungi. Cyclosporine, vital for transplant patients, was discovered in a soil fungus. Researchers continue to scan the fungal kingdom, searching for the next breakthrough hidden in a forest or meadow. For centuries, traditional medicine has leaned on mushrooms, but modern science is revealing just how profound their pharmacological powers are. Each cap, each thread of mycelium, may carry a molecule that could one day save lives. To walk through the woods is, in a sense, to wander through a living pharmacy, where cures are waiting patiently to be discovered, hidden beneath moss and bark, inside the quiet labor of fungi. The first antibiotic, penicillin, came from a fungus. In 1928, Alexander Fleming noticed that a mold, Penicillium notatum, had killed bacteria on a petri dish in his lab. This chance observation led to penicillin, the first widely used antibiotic, which went on to save millions of lives during World War, the Second and beyond. Though not a mushroom, Penicillium belongs to the same great fungal kingdom, showing once again how deeply fungi shape human history. The discovery of penicillin changed medicine forever, turning once deadly infections into treatable conditions. It is awe-inspiring to think that such a monumental shift came not from human invention alone, but from the quiet work of a fungus growing in a forgotten dish. That mold carried within it the power to rewrite the story of medicine, reminding us that fungi are not only recyclers of the forest, but guardians of human survival in ways we never expected. Fungi make bread rise, and wine ferment. Every loaf that lifts in the oven, and every glass that sparkles in the evening, owes a quiet debt to fungi. Yeasts, single-celled cousins of mushrooms, feast on sugars and exhale carbon dioxide and alcohol. In bread dough, those bubbles get trapped in gluten's stretchy net, swelling the loaf like a slow sunrise in wine. The same breath becomes effervescence or the still hush of a finished vintage. A sourdough starter is its own small ecosystem, yeasts, wild and cultured, living alongside friendly bacteria, each adjusting to temperature, flour, and time. Bakers learn to read its mood by scent and sound, a soft hiss like a sleeping tide. Vintners, too, speak of terroir partly in microbial terms, the invisible compositions of local yeasts that bend grapes toward flavor. Fermentation is chemistry, yes, but it is also choreography, fungi moving sugars toward nourishment and celebration, one invisible breath at a time. Mushrooms have inspired entire genres of art. From embroidered folk motifs to gilded illustrated field guides, mushrooms have long crept from the forest floor onto canvas, cloth, and page. Their silhouettes are irresistible. Domes and frills, gills like cathedral vaults, stems that rise with the dancer's poise. Art Nouveau borrowed their curves, botanical illustrators chased their subtle colors. Ceramicists glazed caps in rain-washed sheens. Modern designers riff on the ribbed geometry beneath a cap to dream up lamps, domes, and latticed screens. Photographers go low to the ground to catch bioluminescent halos, turning night woods into constellations. Even children's books lean on the mushroom's fairy tale aura, a symbol of surprise, a door to a small, luminous world. The appeal is more than visual. Mushrooms are metaphors for emergence, for worlds hidden until the conditions are right. Art keeps returning to them because they are both alien and familiar, a language of forms that whispers look closer. Some mushrooms can sing with ultrasonic clicks. Fungi have no mouths, yet researchers recording ultra-sensitive signals have detected faint, click-like bursts as mushrooms grow and mycelium rearranges fluid and pressure in their tissues. Whether these micro-sounds are true singing or simply tiny biomechanical releases is still being explored, but the effect is enchanting. A forest broadcasting at frequencies we rarely notice. In labs, scientists also measure electrical pulses flowing through mycelial threads, rhythmic spikes that speed up, slow down, and cluster like syllables. Artists translate those patterns into audible tones, turning fungal pulses into ambient music that rises and falls with humidity, light, or touch. Listen long enough, and you begin to imagine a choir beneath the soil. Signals coordinating growth, resource sharing, or stress responses, the way a heartbeat and breath set tempo for a body. Whether language or byproduct, the clicks remind us that living structures have rhythms, and the mushroom's rhythm is patient and precise. Fungi have been found living inside rocks. In deserts so dry that wind seems to polish the bones of the world, life retreats into stone. Endolithic fungi tuck themselves within mineral pores, thin as hair and tough as old rope, living where temperatures swing wildly and water arrives as rumor more than rain. In Antarctica's dry valleys, they haunt the translucent skins of quartz, sipping the dim, filtered light that slips a few millimeters deep. Their chemistry is pragmatic and ancient. Acids nibble minerals, pigments buffer radiation, and metabolism slows to the barest ember, ready to flare when a film of meltwater returns. To say life is resilient is too blunt. Life is ingenious. These rock dwellers write their biography in microns, chiseling patience into geology. Open a stone and you may find not emptiness, but a city of filaments, a reminder that habitable is broader than we think, and that the frontier often begins just beneath the skin of the world. Mushrooms can turn ants into zombies. An ant wanders under a leaf screen awning, and a spore alights, a single seed of a fungus that knows its host intimately. Inside, the fungus grows like a whispered suggestion, threading through muscles while sparing the brain just enough to steer behavior. Compelled by chemistry, the ant climbs to a height perfect for dispersal, bites down on a vein in a death grip, and freezes. Then the fruiting stalk emerges, breaking the exoskeleton like a dark flower, releasing spores over the forest path below. This is the infamous zombie ant tail, precise as clockwork and yet still uncanny. It is horror reduced to evolutionary logic. By guiding behavior, the fungus places its offspring in the right wind. Nature does not moralize, it strategizes. And here, strategy is choreography. A climb, a bite, a stillness. Also a mushroom can cast its dust into the moving air. Cordyceps fungi burst out of insects' bodies. Cordyceps are the Gothic poets of the fungal world, turning the small dramas of insect life into strange still lifes. A caterpillar hardens into a pedestal, a beetle becomes soil for a slim orange spear. A spider, arrested mid-pose, sprouts delicate antlers. Each species of cordyceps is specialized, evolved for a particular host. A locant key, intimacy, millions of years in the making. Under the surface, enzymes soften chitin threads, fill hollows. The body is remapped from within until the fungus steps into the light to fruit. The sight is unsettling because it blurs our tidy categories. Animal into architecture, parasite into gardener. Yet cordyceps also returns nutrients to the forest and restrains insect populations, an ecological balance written in eerie sculpture. To notice one is to stand both repelled and transfixed, reminded that survival often takes forms we find beautiful only after the first shiver passes. Some mushrooms look like tiny bird nests. Kneel in damp leaf litter and you may find a thimble-sized cup cradling glossy eggs. These are bird's nest fungi, members of the Nidulariaceae, and those eggs are peridiolae, spore packets ready for a rain-driven ride. When a drop falls, it strikes the cup just right, splashing the peridiolales outward like pebbles from a sling. A sticky cord helps them latch onto passing twigs or fur, hitchhiking toward new ground. The design is perfect physics, scaled to a raindrop. Bold geometry, impact angle, trajectory. They're easy to miss until you've seen them once, and then the forest becomes suddenly full of miniature nests, whole nurseries operating in silence at the top level of the world. Bird's nest fungi collapse distance between whimsy and engineering, a fairy tale form executed with mathematical grace, each rainstorm a drumroll for the next generation. Others look like fingers reaching out of the ground. In shaded corners, clusters of blunt black clubs push from the soil like a hand half-remembered. Dead man's fingers, Xylaria polymorpha, blue-grey at first, then sooty with age. Elsewhere, coral fungi lift pale, branching antlers in delicate chandeliers. These forms trick the eye because they feel gestural, a reaching, a beckoning, when they are simply fruiting bodies tuned to shed spores efficiently in moving air. The macabre names are our own projection, our tendency to find ourselves in everything. Look longer and the theatre quiets. These fingers are wood recyclers, born from buried roots, mapping where a tree once stood. They rise, spall, and weather back to husks, but the mycelium beneath persists, patient as bedrock. It's a useful lesson. Much of a life can be hidden and still be the truest part of the story. Some mushrooms are covered in slime. Gleaming caps bead with a varnish of rain and resin. Some are so slick you could almost see your reflection. The slimy look isn't a quirk so much as strategy. In bolete and Suillus species, a viscid cap helps retain moisture and may protect tender tissue from drying winds. In the brazen stinkhorns, slime the glebe wears a different mask, a foul, sugary lure that mimics decay and draws flies. They land, feed, and leave, wearing spores like dusting powder on their feet, a taxi service paid in trickery. To us, slime reads as a warning, but to mushrooms, it is a toolkit. Hydration layer, raincoat, perfume, billboard. Touch one and your fingertips come away tacky. a tactile memo that the forest is built on function before aesthetics. Even gloss has a job to do. Mushrooms can be bright blue, purple, or pink. Some mornings the forest forgets its birth tones. Indigo milkcaps bleed blue amethyst deceivers scatter jewel-bright petals among brown leaves. Waxcaps rise in sherbet pinks and citrus yellows on old meadows. The colors serve many purposes: pigments that shield from light, antioxidants, signals to insects, or simply chemistry that rides along with other traits. To stumble onto a blue mushroom is to feel a small jolt of disbelief, like finding a tropical fish in a puddle. Photographers chase these moments: a cobalt cap under moss, a violet stem against russet oak. Color, in fungi, is a spectrum of survival strategies and accidents that read as wonder to human eyes. The palette reminds us that forests are not monochrome. They are stained glass windows laid flat, lit from above by cloudlight, painted from below by the quiet chemistry of the soil. Fungi can survive in the harshest deserts. In the dry silence of deserts, where plants curl into thorns and animals vanish into burrows, fungi still persist. Some hide in cryptic forms, living within rocks, shielded from wind and sun. Others cloak themselves in lichens, binding with algae or cyanobacteria to form living skins across stone. These partnerships make food from sunlight, while fungi provide shelter and moisture storage. Even in the Atacama Desert, one of the driest places on Earth, scientists have found fungal life quietly clinging to salt crystals and mineral veins, surviving on fleeting mists and dew. Their resilience is staggering. They can tolerate extremes of heat, cold, drought, and radiation. To imagine fungi thriving where almost nothing else can is to see survival stripped to its essence. Life, through fungi, whispers even in places we call lifeless, proving again and again that the boundaries of possibility are far wider than we dream. Mushrooms once fed the dinosaurs. When dinosaurs thundered through prehistoric forests, fungi were there, breaking down wood, recycling matter, and sometimes feeding the giants directly. Fossil evidence suggests that mushrooms sprouted abundantly in the Cretaceous period, growing in soils rich with decaying vegetation. Some may have been grazed by herbivores alongside ferns and conifers, their fruiting bodies plucked from the ground like snacks. Others partnered with roots, sustaining the forests that dinosaurs depended on. Imagine a sauropod stretching its neck across a swampy clearing, the ground beneath dotted with mushrooms the size of dinner plates. In a world without flowering plants, fungi were already recycling nutrients, keeping the cycle of life spinning. They were both food and infrastructure, feeding individuals and maintaining ecosystems. To think that dinosaurs, icons of raw power, owed something to the humble mushroom is to realize that even giants walk on the quiet foundation fungi weave. Fossil fungi date back over 400 million years. The fossil record is full of bones and shells, but mushrooms leave softer traces, rare and delicate. Still, we have found impressions and mineralized remains of fungi stretching back over 400 million years into the Devonian period. These fossils capture filaments and spores, frozen in ancient sediments, telling us that fungi were already shaping the land, while fish were only just beginning to walk. Some of these fossils preserve mycorrhizal partnerships, proof that even then, fungi were collaborating with plants to colonize bare rock and build soil. It is humbling to hold a piece of stone and know it carries the ghost of a fungus that lived before forests, before insects took to the air, before most life had even left the sea. Each fossil is a window, showing us that fungi are not side players but primeval architects, present at the very birth of the terrestrial world. The oldest fungal fossil is nearly 1 billion years old, In the Canadian Arctic, scientists discovered a fossilized network of filaments so ancient it stretches our imagination, nearly 1 billion years old. This makes fungi among the earliest multicellular organisms ever found, predating plants by hundreds of millions of years. These filaments, preserved in shale, reveal that fungi were experimenting with complex forms long before forests existed, perhaps even before animals evolved. Their presence suggests that fungi may have played a role in preparing Earth for later life, weathering rocks and recycling nutrients in the oceans and on land. To picture a billion-year-old fungus is to confront time on a scale beyond comprehension. These were organisms that thrived in a world utterly alien to ours, yet their descendants still fruit in our gardens and kitchens. Every mushroom we see today is linked by lineage to these ancient pioneers, carrying echoes of a world that barely resembled our own. Mushrooms can form perfect geometric patterns. When mushrooms fruit, they sometimes arrange themselves in startlingly precise patterns. Arcs, spirals, even complete circles. These shapes emerge naturally from the way a mycelium expands outward underground. As it grows, the network exhausts nutrients at the center and pushes outward, sprouting mushrooms at the advancing edge. From above, the result can look almost designed, as though geometry itself had risen from the earth. Spirals may echo the mathematics of growth, similar to shells and sunflowers, where efficiency dictates form. To stumble upon such a pattern in a meadow is to feel as though hidden order has surfaced, nature sketching diagrams in living ink. These patterns remind us that beauty often arises not from intention, but from process. The physics of expansion, the flow of nutrients, the silent hand of time. Mushrooms are mathematicians too, etching quiet symmetries beneath the forest canopy. Some spores are designed to hitch rides on insects. Not all spores drift aimlessly in the air. Some are crafted to cling, spiky, sticky, or wrapped in hooks that catch on the legs, wings, or fur of passing insects. Insects become unwitting couriers, scattering spores to new territories far beyond the reach of wind alone. Certain fungi take this partnership further. They attract insects with sugary exudates or glowing signals, ensuring close contact. Others grow on flowers or leaves, precisely where pollinators brush past. The strategy is ingenious. Why rely on chance when you can recruit travelers already moving across the landscape? For the insect, the exchange is invisible. For the fungus, it is survival extended through hitchhiking. The forest is full of these silent exchanges, where movement is currency, and spores ride on wings like passengers boarding flights into the unknown, trusting in the restless wanderings of the tiny creatures of the air. Mushrooms help lock nutrients into soil. Fungi are the recyclers of the world, breaking down dead leaves, wood, and organic matter into simpler forms. But they do more than release nutrients. They help hold them in place. Mycelium binds soil particles together, preventing nutrients from washing away with rain. In forests, this creates a kind of living sponge beneath the surface, storing phosphorus, nitrogen, and carbon where roots can reach them. Without fungi, soils would quickly lose fertility, leaving plants malnourished. Even in agriculture, fungi play this role, keeping nutrients stable and available to crops. Imagine the underground web as a careful steward, tucking nutrients safely into pockets until they are needed. In this way, fungi act as both recyclers and guardians, ensuring that the richness of the land endures. They are keepers of fertility, invisible custodians of soil health, maintaining the quiet balance that supports forests and fields alike. Fungi create entire underground highways for microbes. Mycelium is not only a network for itself, but also for others. Studies have shown that bacteria use fungal threads like highways. traveling along them to spread through soil more efficiently. The thin filaments provide a stable surface, guiding microbes across otherwise impassable gaps. In return, bacteria sometimes share nutrients or aid the fungus, forming miniature partnerships. This creates an underground infrastructure where countless microscopic species coexist and interact. It is a hidden ecosystem of highways, junctions, and exchanges, invisible yet vital. Without fungi, many microbes would be stranded in tiny soil pockets, unable to disperse. With them, the ground becomes a bustling metropolis, full of traffic and trade. To imagine soil as empty dirt is a mistake. It is more like a city thrumming with connections. And fungi, with their endless threads, are the engineers, laying down roads for life to travel. Some mushrooms smell exactly like fresh bread. Lift the cap of a freshly picked champignon or a field mushroom, and you may notice a fragrance startlingly familiar, warm, yeasty bread straight from the oven. This aroma comes from volatile compounds also produced by yeasts during fermentation, shared chemistry that links fungi to baking. For foragers, the scent can be a clue to identification, a sensory handshake between species. The smell is more than pleasant, it is evolutionary strategy. Aromatic compounds can attract insects or animals, encouraging them to brush against spores and carry them onward. For humans, the connection feels almost uncanny. To breathe in the fragrance of bread in the middle of a forest is to experience comfort in an unexpected place, as though the kitchen and the wild had momentarily merged. It's a reminder that the boundaries we imagine between the cultivated and the natural are often thinner than they seem. Others smell like cinnamon or anise. Not all mushrooms carry earthy or musty aromas. Some release perfumes that mimic spices from distant kitchens. Aniseed toadstools exude the sweet, licorice-like fragrance of anise, while certain milk caps smell distinctly of cinnamon. These aromas come from aromatic compounds, identical or similar to those in the spices themselves. For humans, the discovery feels magical, walking through damp woods only to stumble upon the scent of a spice drawer. But for the fungi, these scents are functional, signals to attract insects or ward off predators. Their chemistry is survival, even if it registers to us as delight. Mycologists often rely on smell as part of identification, bending low to inhale the secret signatures of species. Each aroma is a note in the symphony of the forest, invisible yet unmistakable. A reminder that mushrooms are chemists as much as recyclers, distilling the air into fragrances we carry with us long after. Mushrooms can absorb and store water like sponges. When rain falls, mushrooms swell quickly, sometimes doubling their weight in a single night. Their tissues are made of chitin and specialized cells that act like tiny reservoirs, soaking up water with astonishing efficiency. This ability allows them to fruit suddenly after storms, appearing almost overnight in meadows and forests. But the water is not just for the mushroom. The absorbed moisture can slowly release back into surrounding soil, creating microhabitats for insects, mosses, and seedlings. In this way, mushrooms act as living sponges, regulating humidity and supporting life far beyond themselves. For foragers, the waterlogged flesh of certain mushrooms is a familiar sign of their adaptability. In ecosystems, it is survival strategy turned into generosity. Rain captured, stored, and shared. Each mushroom is more than a fruiting body. It is a vessel, carrying the memory of rainfall and releasing it gently into the rhythms of the forest. Some fungi can glow for days without stopping. Bioluminescent mushrooms are natural lanterns, glowing with a greenish light in the dark of the forest. Unlike fireflies, which flash briefly, some fungi glow continuously for days or even weeks. This light comes from a chemical dance between luciferin and luciferase, the same reaction seen in other glowing organisms. Scientists believe the glow may attract insects at night, spreading spores farther than the wind could carry. Imagine walking through a rainforest and seeing clusters of mushrooms shining softly under ferns, like embers scattered across the ground. The glow is steady, patient, and strangely comforting, a quiet reminder that life does not sleep when the sun goes down. For centuries, travelers called it foxfire or fairy fire, stories rising from the eerie beauty of glowing logs. Today, we know the chemistry, but the magic remains. Fungi painting the night with a light that seems to come from within the earth itself. Mushrooms have been used in traditional ceremonies worldwide. For thousands of years, cultures across the globe have turned to mushrooms in spiritual practice. In Mesoamerica, the Aztecs spoke of Teononacatl, the flesh of the gods, used in rituals to bridge the human and divine. In Siberia, shamans consumed Amanita muscaria, the iconic redand-white mushroom, seeking visions and altered states of consciousness. Indigenous peoples in Africa, Asia, and the Americas wove mushrooms into healing ceremonies, fertility rites, and initiations, treating them as portals to wisdom. These practices recognized something we still grapple with today, that mushrooms are liminal beings, living between life and decay, dark and light, seen and unseen. Even now, mushrooms remain part of modern spiritual movements and medicine, studied for their potential to ease anxiety, depression, and existential fear. Across continents and centuries, they have been not just food or poison, but symbols of mystery and transcendence, guides to worlds within and beyond ourselves. Certain mushrooms can jump their spores into the air. Most mushrooms rely on wind or rain to scatter spores, but some use extraordinary mechanics. In inky caps and puffballs, pressure builds until spores are released in smoky bursts. Other species, like Bioluminescent, go even further. They launch spores with explosive force, shooting them several meters away. The trick lies in building pressure inside microscopic sacs, then releasing it in a split second, sending spores flying like tiny cannonballs. To humanize, the act is invisible, but under microscopes it looks like fireworks in miniature. This strategy ensures spores escape the shadow of the parent, landing in open ground where they have a chance to thrive. The forest, when seen at the fungal scale, is alive with invisible projectiles, clouds, bursts, and jumps carrying the next generation forward. What feels like stillness is actually motion, spores leaping constantly into the unseen currents of air. The fastest living movement on Earth belongs to a fungus. Speed records in nature are usually reserved for animals. A cheetah's sprint, a mantis shrimp's punch. But the fastest known living movement belongs to a fungus. Pilobulus, a tiny dun-loving fungus, can launch its spores at speeds exceeding 20 meters per second, with accelerations greater than a bullet leaving a gun. The spores are encased in pressurized capsules that build tension until they rupture, catapulting the payload with astonishing force. For something so small, the distance traveled is monumental. Sometimes more than 2 meters, 100 times the height of the fungus itself. This ensures spores land on fresh grass, ready to be eaten by grazing animals and carried onward. To realize that the fastest motion in biology is not a predator's strike but a mushroom's spore launch, is to see power in an unexpected place. Fungi prove again, but wonder often hides in the overlooked. Some mushrooms resemble coral or sea creatures. On the forest floor, coral fungi rise in branching patterns that mirror ocean reefs. Pale white or brilliant orange, they fork and twist into miniature underwater landscapes transposed onto land. To stumble upon them is to feel as though the sea has spilled into the woods, waveforms fossilized in living form. These resemblances are not coincidental, but the product of efficient growth patterns. Branching maximizes surface area, allowing more spores to be released into the air. The result, though, is sculpture. Fungi that look like antlers, coral, or flames. Some are delicate as lace, others thick as bone. Each a reminder of how life reuses shapes across environments. Coral in the sea, fungi on land. Both are architects, building from repetition, branching into beauty. To see them is to witness a design language older than either reef or forest, repeating itself in quiet harmony across worlds. Others look like tiny umbrellas or parasols. In damp meadows after rain, clusters of delicate mushrooms rise, their caps spreading like miniature umbrellas. Some are translucent, thin as tissue paper, glowing softly when backlit by sunlight. These dainty fungi often last only a day or two before collapsing, their beauty fleeting as a morning dew. Yet in their brief lives, they capture the imagination. Parasols for insects, tiny shelters on the forest floor. Their form is both practical and poetic. The cap protects spore-bearing gills beneath, while the stalk lifts them into air currents. Evolution has shaped them into icons of simplicity, instantly recognizable across cultures as the mushroom shape. Children draw them instinctively, fairy tales decorate them with spots, and biologists study their mechanics. They are ephemeral, yes, but unforgettable. A design so elegant it has become the symbol of the entire fungal kingdom, rising in miniature with every rain. Fungi may hold the key to carbon capture. One of the greatest challenges of our age is pulling carbon dioxide out of the atmosphere, and fungi may offer part of the solution. Mycorrhizal fungi, in particular, form partnerships with trees that increase carbon storage underground. By channeling sugars from plants into deep soils, fungi help lock carbon away for centuries, preventing it from returning to the air. Some fungi even produce compounds that resist decay, effectively sequestering carbon in stable forms. Scientists are studying how fungal networks could be encouraged to enhance this effect, potentially turning forests and soils into more powerful carbon sinks. Imagine climate change countered not only with machines, but with living systems, invisible threads weaving carbon back into the earth. In the quiet work of fungi lies a potential ally against the warming of our planet, proving that solutions may already be under our feet, waiting patiently to be recognized. Mushrooms could help terraform other planets. If humans one day colonize Mars or other worlds, fungi may be among our most trusted companions. Their resilience makes them candidates for breaking down rock into soil, producing food, and even recycling waste in closed environments. Some fungi can tolerate radiation and low gravity, making them useful for building life support systems in space. Mycelium could even form construction material, lightweight, strong, and biodegradable structures grown instead of manufactured. Scientists already imagine fungal biodomes where habitats are not built, but cultivated, expanding like living architecture. This vision echoes Earth's own history, when fungi helped prepare the land for plants hundreds of millions of years ago. They were pioneers once, and they could be again, carrying their ancient skills into alien landscapes. If humanity ever spreads beyond Earth, it may not go alone. Fungi may weave the foundations of our new worlds, just as they did this one. Without fungi, life on Earth would not be possible. Strip fungi from the planet, and life collapses. Forests would choke on their own litter, nutrients would vanish from soils, and cycles of decay and renewal would grind to a halt. Without fungal partnerships, most plants could not absorb enough nutrients to survive, and without plants, animals, including humans, would have no food. Even the oxygen we breathe owes part of its balance to fungi, which sustain ecosystems that produce and recycle it. Fungi are the recyclers, the partners, the healers, the quiet engineers of Earth. They work unseen, yet their absence would be catastrophic. Every meal, every breath, every green landscape exists because fungi are there, balancing the system. To understand this is to realize that mushrooms are not side characters in the story of life. They are its foundation. Without them, the stage would be empty, and the play of life could never begin. And so we drift to the end of our quiet journey through the kingdom of mushrooms. From glowing lanterns in the forest night, to spores riding invisible winds above the city, to fungal networks older than forests themselves, we've wandered through a world that is at once hidden and essential, fragile, indestructible. Mushrooms remind us that life is not always loud or visible. Much of the work of this planet is carried out in silence, beneath our feet, in threads so fine they can slip through the pores of stone. Fungi teach patience, resilience, and transformation. They recycle death into life, store water for the thirsty, feed giants and insects alike, and even whisper to plants through underground networks. Without them, there would be no bread rising in ovens, no forests climbing toward the sky, no balance in the endless cycles of Earth. As you let these thoughts settle, imagine the slow pulse of the mycelium beneath you, a heartbeat of the soil, steady and calm. Imagine spores drifting like stardust, carrying possibility into every corner of the air. Imagine the glow of mushrooms in the dark, quiet beacons to remind you that even in shadow, life continues to shine. This is the comfort of science told slowly, that the world is stranger, richer, and more interconnected than we can ever fully see, and that by pausing to notice, we glimpse the extraordinary in the ordinary. If you've enjoyed this journey, and you'd like to drift through more worlds of curiosity and wonder, we'd love for you to like, subscribe, and share your thoughts in the comments. It helps our little community of dreamers and science lovers grow. But for now, there is nothing more you need to do. You can allow the story of mushrooms to fade, like the last light of day, leaving only calmness behind. If sleep comes, let it carry you gently. If you are still awake, you are welcome to stay, to listen again, or to let the next video continue your voyage into the quiet wonders of the universe. Rest well, and remember, the world is full of hidden marvels. Sometimes they rise overnight like mushrooms after rain. Sometimes they have been waiting for you all along, beneath the surface. Good night.